That we are told to simplify this exponential equation. Now let us work with the denominator first. So here we have x raised to the power of 2n plus 1 all over x raised to the power of 2n now plus 5 all over 2. Now the square root here, let us take note that according to the law of indices, when you have the square root of a, it equals to a raised to the power of 1 over what? 2. Okay? And if that is true, so we can say this is x raised to the power of 2n minus 3 all raised to the power of 1 all over 2. Okay? And we know also that, let's recall also that when you have a raised to the power of m or raised to the power of n, we will need to multiply the power, which implies that a will now be n m. Alright, so the power will be multiplied. So to that stand, let us use that with this. So here we have x raised to the power of 2n plus 1, which is the numerator, all over x raised to the power of 2n plus 5 all over 2. Now times, then here you have x raised to the power of 2n all over 2 plus 3 all over 2. Alright, you might be wondering why. Now let us look at this. You have x now raised to the power of 2n, then minus 3. Now all raised to the power of 1 all over 2. Now ideally we are meant to multiply the exponent in the bracket and that of the outside. So if we tend to multiply this, now we have x raised to the power of 2n minus 3 all over what? 2. Okay? Alright, so to this stand now, this also implies x, since it has a common denominator, then we can split it this way: 2n all over 2 minus 3 all over what? 2. So that's how I got this. Alright, now to this stand now we can now say x raised to the power of 2n plus 1 all over x raised to the power of 2n plus 5 all over 2. Now times, now we can eliminate 2 and 2 here, right? So here we have x raised to the power of n minus 3 all over 2. Also, let's recall that if you have x raised to the power of a times x raised to the power of b, this will give us x raised to the power of a plus b, as long as the base are the same. So what we need to do is to add the exponent or the power, and you can see that this law aligns with what we have here at the numerator. So what we need to do now is to add both the exponent. Okay, now let me quickly solve that. Here we have 2n plus 5 all over 2, then plus n minus 3 all over 2. Now let us collect like term. Here we have 2n plus n, then plus 5 all over 2 minus 3 all over 2, and this will give us what? 3n, then plus, now here only this gives us since it has a common term, so we have 2 here, we have what? 5 minus 3, which will give us what? 2 all over 2, which will give us what? 1. So here you have 1. So at the end of the day, here we have x raised to the power of what? 2n plus 1, then all over. Now for the numerator, the denominator, the power, the whole of this becomes x raised to the power of 3n plus 1. Alright, so at this point here now we know that according to the law of indices, if you have x raised to the power of a all over x raised to the power of b, so long they have the same base, then we'll have it as a x raised to the power of what? A minus b. Now if you look at this expression, now you will see it's the same thing as this, so it implies here then we're going to say that this is x raised to the power of what, 2n plus 1, then minus into bracket 3n plus 1. Okay, so this will give us x raised to the power of 2n plus 1 minus 3n minus 1. Alright, so this will give us x raised to the power of 2n minus 3n then plus 1 minus 1. So finally, plus 1 minus 1 will give us 0. So here we have x raised to the power of 2n minus 3n will give us negative n. Alright, so at the end of the day, we have 1 all over x raised to the power of n. Final answer. Either you leave it in index form or in fraction. Alright, if you love what I does do, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in mathematics. Thank you and God bless you.